Right, I'm going to try and go through parallax, parsecs and all that sort of stuff. It's the third time I've tried this video. I keep getting into difficulty. You're going to have to show me how I edit videos afterwards. Right, okay, first thing we need to be able to draw a diagram to show what we mean by parallax. So, first thing, that's the sun there. We've got the Earth orbits the sun, okay? And we're interested in the Earth when it's at that point there and that point there on my diagram, okay? Now you can see between that point there and that point there, that distance, I'm going to call it R, because it's the radius of the orbit, but we know the radius of the Earth's orbit, we call it 1 astronomical unit, and we know that's equal to 1.5 times 10 to the 11 metres. Now, this distance here, you're not given in the exam, so I suggest you learn it because it's going to be helpful. You are given what 1 parsec is in metres, you are given what 1 light year is in metres, and you could work that out. You're not given the astronomical unit, the distance between the sun and the Earth, the average distance, so please learn it. Okay, now, the other things you need in your diagram, you need a background of stars, okay? So there's my stars all the way over here, and we're interested in a star that's much nearer to the Earth. Let's have our star nearer to the Earth being there. Now, can you see that when we're orbiting, when we're at this stage, where that star will appear to be would be, if I draw a straight line there to there, that star appears to be here against these stars that are far away. 6 months later, we come round to this side. If we see where that star looks like it is, it now looks like it's over this side. So it's moved from there to there. And if it's moved, what we can do is we can measure the angle at which it's moved. Now, the distance we want is the distance from the star that we want to measure the distance away from, and the sun. So I'm going to call that D. And this angle here, I'm going to call theta. Now, using your basic trigonometry, you know that tan theta is equal to opposite over adjacent. By the way, this is the diagram you'll need. You'll need to label this here as the parallax. Parallax, it's spelled correctly up above. Okay, tan theta is equal to opposite over adjacent. On the diagram, my opposite is R, my adjacent is D. So I've got tan theta equals R over D. And I know what R is. R is 1.5 times 10 to the 11. Rearrange that. I can calculate the distance because the distance would be equal to R divided by tan theta. Okay, now, just a couple of things. First thing that we look at is this all works, and it will all work beautifully in SI units, but is often simplified to D equals R over theta. Now, where does the tan go? Well, you mathematicians might already know this, but for very small angles, and if you think about it, this angle is going to be very small because this distance here is going to be tiny compared to this distance here. For very small angles, theta is around the same as tan theta. Okay, this only works for small angles, and it works when we're using radians. Let me just prove it to you. Here's my calculator. If I put in the tan of a small number, so let's have 6.625 times 10 to the minus 4. If I do tan of 6.625 times 10 to the minus 4, look, I get around the same answer. So that's why we can get rid of the tan, and that's where we can come up with that equation from. Now, just to show you that equation, we'll have a look and see what distances we come up with. Now, a parsec is defined, and you'll need to know the definition. A star is exactly 1 parsec away from the Earth if the angle of parallax, that's theta, as the Earth moves through 1 AU is 1 second of arc. Now, 1 second of arc is 1 over 3,600 degrees, okay? That's the definition of 1 arc second. 1 degree can be split into 60 arc minutes, and each arc minute can be split into 60 arc seconds. So 1 arc second would be equal to that in degrees. Now, if we're going to find out then what a parsec is, we can use this equation, but using this equation that we've just derived, we've got to use SI units. So to find the distance in metres away from a star, away from the Earth or away from the Sun, the star would be, if the parallax was this, I've got to put R in metres. Well, I know what R is. It's 1.5 times 10 to the 11. And I've got to put theta in radians. Okay. Now, 1 over 3,600 is what it's in degrees. So if I just want to change that into radians, well, I know that 360 degrees is equal to 2 pi radians. And so I know 1 degree is equal to 2 pi over 360 radians. So 1 over 3,600 degrees would be equal to 1 over 3,600 times 2 pi divided by 360 radians. Okay, you mathematicians will be much better at this than I am. So if I do that, if I do, let's have a look, 1 divided by 3,600, and then if I multiply that by 2 pi and divide it by 360, I get an answer of 4.85 times 10 to the minus 6 radians. So to find the distance, I would do 1.5 times 10 to the 11 divided by that angle in radians, and what happens is it comes up to be 3.1 times 10 to the 16 metres, which that is what 1 parsec is in metres. So all of this works beautifully if we're using SI units. You need to be able to draw that diagram, and you need to be able to come up with, well, at least that bit of the equation, if not going down to that bit of the equation. Then what we've got to look at is, well, actually we're given a slightly different equation and to work out distances if we know the parallax. And the distance that the equation that we're given is D is equal to 1 over P. So you can rearrange that. P is equal to 1 over D. Now it's the same equation as this equation here, apart from they've defined the units as such that it will work out that we don't have to put the radius of the Earth in. They've defined the units so it works out with that 1. And how they've defined the units is that you're going to find D in parsec. So you're not going to find D in metres. D will come up in parsec. And we have to use the parsec you have to put in arc seconds. Okay, so this is the same equation, but they've done a cheat. They've redefined all the units so that you've got the distance in parsec, and you've got the parallax in arc seconds. So we're going to have a look and see how we can actually use that to be able to do a question. So we might get a question that says that a star has got a parallax of 5 times 10 to the minus 5 degrees. Okay, so question might give you the parallax, I keep missing that A out, parallax of a star as 5 times 10 to the minus 5 degrees. And we've got to work out the distance from Earth. Right, well, we know the equation straight away. Distance is equal to 1 divided by parallax. However, as I said, to be able to use this equation, we're going to get our distance in parsec. We've got to put the parallax in arc seconds. And at the moment, that's in degrees, not arc seconds. So first thing we have to do is to change that into arc seconds. So we're going to do 1 divided by the parallax in arc seconds is going to be 5 times 10 to the minus 5. Well, that's in degrees, isn't it? And an arc second is 1 over 3,600. So if I multiply that by 3,600, I should get it in arc seconds. Okay, so if I just do that bit that bottom bit of the equation first of all. I've got 5 times 10 to the minus 5 multiplied by 3,600. That comes out to be 0.18 arc seconds. So 1 divided by 0.18 arc seconds. If I do 1 divided by that, I get an answer of 5.5 reoccurring, so 5.6 to two significant figures. And because we're using this equation, that's going to be in parsec. Okay, so the big thing is using this equation. This works because they've changed the units so that they've made a definition of what those units are. That distance will come out to be in parsec if that parallax is given in arc seconds. And 1 degree is made up of 3,600 arc seconds. Comment if there's something else you want me to go through.